Solubility and saturation. The ability of a solvent to dissolve a solute depends on the forces of attraction that are between these particles. The solubility of a solute is the amount of solute that dissolves in a given quantity of solvent at a certain temperature. So depending on the temperature of the solvent will determine how much solute can dissolve within a certain given amount. So here's an example. The solubility of sodium chloride, the example as we mentioned, the salt dissolving in the water. If we were to have it at 20 degrees Celsius, we can dissolve 36 grams within a 100 milliliter volume of water. So if I had 36 grams of salt, or actually if I had, let's say, 40 grams of salt in the same 100 milliliter beaker of water, I will only be able to dissolve 36 grams, which will leave an excess of 4 grams that will not be able to dissolve. So at 20 degrees, that's the amount. If I want to increase the amount that I can dissolve in water of salt, I'd have to raise this temperature. So a saturated solution is formed when no more solute, it will dissolve in a solution and excess solute is present. So example, 100 milliliters of a saturated solution of table salt, NaCl, in water at 20 degrees Celsius contains 36 grams of sodium chloride. The solution is saturated with respect to sodium chloride. So if we've been able to dissolve the maximum amount that we can within a given volume, that's considered a saturated solution. It's got the most that it can hold in that volume that we're given. Now, an unsaturated solution is a solution that is not yet saturated, which means there's room to add more solute so we can dissolve it. So if at 20 degrees Celsius, we can dissolve 36 grams, which means I can dissolve, let's say, 20 grams at that same temperature in 100 milliliters of water, which means I have still room for another 16 grams to be able to dissolve. So which means if I'm only dissolving 20 grams of salt in that volume of water, it means that I am technically still, I've got an unsaturated solution. I have not pretty much reached my capacity for the amount of solute that can actually possibly be dissolved within these 100 milliliters of water. All substances dissolve in one another. If a solute is considered soluble, then its solubility is considered greater than 1 gram of solute per 100 milliliters of solvent. So which means if I'm able to dissolve a minimum of about 1 gram per 100 milliliters or more, so this is the minimum that I'm able to dissolve within 100 milliliters of water, then I know that my solute is soluble in the solvent. If something is considered insoluble, its solubility is less than 0.1 grams of solute per 100 milliliters of solvent. So we're thinking, well, we said the term insoluble. We're thinking, well, insoluble, you cannot be able to dissolve. But no, the thing is, the term insoluble, not being able to allow for something to dissolve, is a relative term. So technically everything, including water and oil, is even though it's insoluble, there's still a small, tiny, smidgen percentage of possible solute that can actually be dissolved in the solute. And the only thing is, though, the amount is so negligible that it's not even considered. Right? You're looking at 0.1 grams that can actually be dissolved in a 100 milliliter volume of a solvent. So it's so little that we consider it insoluble, but technically there is some slight bit of solubility that is actually present. So substances with these extremely low limits are called slightly soluble or sparingly soluble, right? But technically they're insoluble. We consider them insoluble, but there is some bit, and we'll expand on this in a later chapter. Now, these levels of solubility do not apply if the solute is a gas. Solubility of oxygen in fresh water at 20 degrees Celsius is only 0.0009 grams per 100 milliliters of water. We said if we had 0.1 grams that can dissolve within a 100 milliliter volume, we're considering that insoluble. But because this is a gas, that rule does not apply. Because look at that, that's way less than 0.1 grams. But oxygen can readily dissolve in water. But in gas form, it gets thrown out the window. That number, we don't really use it. We use it more for solids within liquids and liquids within liquids, but never gases in liquids as such. So this small amount is enough to ensure the survival of aquatic plants and animals.